Hi everyone, the channel Easy Lecture welcomes you. In this video we are going to discuss signal manipulation as that of previous video. In previous video we discussed mainly the amplitude scaling and time shifting operation that involve in a certain kind of signal. For that we considered an example problem. We considered a problem that was asked in Anna University semester examination and we discussed those ideas. In this video we are going to discuss time shifting, time scaling and time reversal operations on signal, and here also we are going to take a problem that was asked in Anna University semester examination under the subject code EC8352 in the year April-May 2019. Before entering into the video, subscribe my channel Easy Lecture. Now let us go for further discussion. So here a signal is given. So this is the question asked in the semester examination. The question is, a continuous time signal x of t is shown in figure below. Sketch and label each of the following signals: x of t minus 2, x of 2t plus 3, x of 3 by 2 into t, and x of minus t plus 1. Okay, so here a signal is given, x of t is given. For that we have to find x of t minus 2. So time shifting operation, x of 2t plus 3, time shifted and also time scaled signal, x of 3 by 2 into t, time scaled signal, x of minus t plus 1, time shifted and time reversed signal. Okay, so these are the things that we are going to see in this video. So here there are two approaches to solve these kinds of problems. One is the traditional approach, another one is the logical approach. Okay, so we are going to discuss both the things in this video. Okay, now let us first do x of t minus 2. X of t minus 2, so there is no negative sign before t, whereas after t there is a value with magnitude with negative magnitude. Okay, with sign negative. So that indicates that since t is positive and following that t there is a number with negative value, we can conclude that it is a time delayed signal. Okay, so time delayed signal, x of t is time delayed by 2 units, time delayed by 2 units. So that means here x of t, what happens, what appears at minus 1 for x of t should appear at minus 1 plus 2, that is equal to 1 at x of t minus 2. So x of t minus 2 at for x of t minus 2, the same thing should be at the thing that is happening at minus 1 should happen at 1. So this is the thing. Okay, and the thing that is happening at 0 should happen at 0 plus 2, that is 2. Okay, the thing that is happening at t equal to 1 should happen at 1 plus 2, that is equal to 3, and the thing that is happening at 2 should happen at 4 at t equal to 4. So this is time shifting operation, and moreover to be specific, it is time delayed operation. The thing that is happening is delayed by 2 time units and then it is occurring, okay, after making this signal to execute. Okay, so this is the thing. And if we have x of t plus 2 instead of x of t minus 2, okay, so suppose we need to find x of t plus 2. So in this case we have to do time advanced operation. Okay, so instead of occurring at minus 1, it should occur at 2 time units before, earlier. Okay, so minus 1, the thing that is happening at t equal to minus 1 for x of t should happen at t equal to minus 3 for x of t plus 2, and the thing that is happening at t equal to 0 for x of t should happen at t equal to minus 2 for x of t plus 2. So this is the thing. So the entire signal is shifted by 2 units towards the left hand side. So here you should not get confused, since minus is there and so the signal should be shifted left. No, it is not like that. Okay, so whenever we do any operations with respect to time, the sign that is given in that is denoted in the signal should take opposite meaning when we execute it. Okay, because time is an inverse operation. For example, when we are traveling to a place, so when we increase the speed, we are increasing the speed actually, then the time taken to reach the destination is decreased, time is decreased. Okay, and when we decrease the speed, the time taken to reach the destination is increased. So in this manner, the time, whatever the operation that we do with respect to time, should take an opposite meaning when we execute it. So this is the thing. And so here it is happening. This is x of t minus 2 for x of t that we have got. So initially x of t was minus 1 to 0. It was a ramp signal. From 1 to 2, from 0 to 1 there is an amplitude of 2, and from 1 to 2 there is an amplitude of 1, and at 2 the signal is ending. So the same signal is shifted by 2 units and it is delayed by 2 units. Okay, so that is why we call it as x of t minus 2. Okay, so this is the thing. And next, instead of discussing x of 2t plus 3 and x of 3 by 2 into t, we shall do x of minus t plus 1. Okay, so here when we speak about x of minus t plus 1, there are two operations involved. Okay, time shifting operation is happening and time reversal operation is happening, because t takes a negative sign, so we can say that time reversal operation is happening there. Okay, in some cases we may be having all the three operations: time shifting, time scaling, time reversal. So if we have time scaling in this kind of signal, there will be a amplitude a. So I am notating the amplitude by a variable a, indicating that the time is weighted by a variable, by a value. Okay, so at that time we can say that all the things are happening: time shifting, time scaling, and time reversal. Okay, so I told you these kind of problems may be encountered in two approaches. One is traditional method. So when we go for traditional method, we have to follow this order. We have to follow time shifting, time scaling, time reversal. So the thing should be performed in this order on the signal x of t to get x of minus t plus 1. So time shifting means we have to first perform x of t plus 1. Okay, and if we have any time scaling, if the time is weighted by any value, we have to perform that. Okay, and after that, at last we have to perform time reversal. So here we have only time shifting and time reversal. So we will be performing time shifting first and then time reversal next. Only then it will give the correct result. Okay, so let us do here. So x of t, for that x of t we are performing x of t plus 1. So t plus 1 means here plus is there, which indicate the signal should be advanced by 1 unit, 1 time unit. Okay, so it should happen earlier. The thing that is happening in minus 1 second should happen at minus 2 seconds. The thing that is happening at 0th second should happen at 1 second earlier, that is minus 1 second. So in this manner we have got x of t plus 1 at time advanced version of x of t by 1 unit. Okay, now for this x of t plus 1 we have to perform time reversal. So first we have performed time shifting, now we have to perform time reversal operation. So that we are doing here. So time reversal operation means whatever the thing that is that happened at minus 2 should happen at 2. Whatever the thing that happened at minus 1 should happen at plus 1. Whatever the thing that happened at 0 should happen at 0, and whatever happened at 1 should happen at minus 1. Whatever happened at 2 should happen at minus 2. So this is time reversal operation. Between minus 2 and minus 1, here in x of t plus 1 we had a ramp signal. So that should be made to happen between 2 and 1. Instead of minus 2 to minus 1, a ramp signal is there. Here in x of minus t plus 1, between plus 2 and plus 1, ramp signal should be there. So that we have got here. Okay, then from minus 1 to 0 the amplitude is 2, and this should be shifted. Between plus 1 and 0 the amplitude should be 2. Okay, then here between 0 and 1 the amplitude is 1. So that should be shifted like this. Between 0 and minus 1 the amplitude should be 1. Okay, so now we have to complete the signal. Okay, so now we have got x of minus t plus 1. So this is a traditional approach. Okay, now a logical approach. Okay, so logical approach means we can make use of this notation minus t plus 1. Okay, so we can directly write from x of t. We know the signal x of t. From x of t we can directly plot x of minus t plus 1 through this logical approach. The thing that we have to do is we have to perform this kind of time operations. So to make the thing to particularly spot to identify the location at which for example, here in actual signal we had from -1 to 0 there is a ramp signal. So to identify the position of this ramp in this x of minus t plus 1 directly, we have to identify the position. To identify the position, we can make use of this mathematical operations. So minus t plus 1 equal to minus 1 which implies t equal to, so plus 1 when it is minus 2, so t equal to 2. Then minus t plus 1 equal to 0 which implies t equal to 1. Minus t plus 1 equal to 1 which implies t equal to 0. Minus t plus 1 equal to 2 which implies t equal to minus 1. Okay, so which means x of t, what happened between minus 1 and 0, it should happen between 2 and 1 for x of minus t plus 1. Okay, the thing that happened between 0 and 1, between t equal to 0 and 1 for x of t should happen between 1 and 0 for x of minus t plus 1. Okay, the signal that happened between 1 and 2 for x of t should happen between 0 and minus 1 for x of minus t plus 1. So in this manner we can conclude. Okay, so this is the logical operation, and this logical approach we can apply to any problem. We can apply to any problem. Even if we forget that order, we may have confusion which order to choose first, either time shifting or time scaling or time reversal, which operation we should take first. So if we have that kind of confusions, and that kind of confusion is avoided completely here, because it is a general approach which is suitable for all kinds of problems. Okay, right. So here I have done here, so minus t plus 1, that's the same thing. For x of t, the thing happened between minus 1 and 0 is happening between 2 and 1. Okay, so for x of t between minus 1 and 0, we had a ramp signal. The same ramp signal is happening between 2 and 1. Okay, and between 0 and 1, the amplitude was 2 for x of t. So here between 1 and 0, the amplitude has become 2. And between 1 and 2, the amplitude was 1 in x of t. Here between 0 and minus 1, the amplitude has become 1. Okay, so here the amplitude is 1, here the amplitude is 2. Right? So in this manner we can solve this problem. We can apply this logical approach to all the problems. Okay. Now let us do the next one, x of 3 by 2 into t. So here it is a time scaling approach. So time scaling approach means, as I mentioned here, the time t is multiplied by a value. Okay, so when it is multiplied by a value, it is multiplied by a value which is greater than 1. Okay, so 3 by 2 means it is 1.5 which is greater than 1. So you may have confusions that the signal after being executed, after performing this kind of scaling operation, it should expand or it should compress, it should get compressed. So the thing is, it should get compressed when the weighted value, the value by which t is being weighted is greater than 1, the signal gets compressed. The value by which t is getting weighted is less than 1 means the signal is expanded. Okay, so to make this possible, we have to actually divide the value by which t is weighted, okay, to identify the exact position of time scaling operation, after time scaling operation. Okay, so here we have 3 by 2 into t. Okay, so to identify the position of the signal that happened between minus 1 and 0. Okay, so the signal that happened for x of t at minus 1, to identify that particular position, we have to divide minus 1 divided by the value by which t is weighted, that is 3 by 2. So which means minus 2 by 3, that is equal to minus 0.6666. So we can write it as minus 0.67. Okay, and the thing that happened at 0 for x of t should happen at 0 divided by 3 by 2, that is equal to 0. Okay, then the thing that happened at 1 for x of t should happen at 1 divided by 3 by 2, that is equal to 2 by 3, that is equal to 0.67 for x of 3 by 2 into t. Okay, so in this manner we have to perform. We have to actually divide the factor by which t is getting weighted or t is getting multiplied. Okay, to identify the actual position. Okay, and again this is the traditional approach that we apply. Okay, so here the logic is, even if the value by which t is multiplied is greater than 1, the actual signal is getting compressed. The fact is, here it means we are playing, so if let us assume that we are playing a music in a music player, and if we are playing it by 2x speed, that means, so here the x speed, it is multiplied by a value 2, but the time required for the completion of that particular song is getting diminished. That means the signal is compressed. Okay, so the same kind of logic is applicable here also. Okay, so here x of 3 by 2 into t means that value, the variable t is multiplied by a value which is greater than 1, so it should happen at a faster rate. So that is the meaning here. Okay, that is the meaning conveyed here. It should happen at a faster rate. So for the entire signal to happen between -1 and 2, x of t is happening between -1 and +2, so the entire signal is getting compressed, since the value by which t is multiplied is greater than 1, and here it happens between -0.67 to 1.33. Okay, so -0.67 into -0.67 to 1.33, the total time duration is 2. Between 1.33 and 0.67, the total time duration is 2. So 1.33 minus of -0.67, the total time duration is equal to 2, which is nothing but the total time duration of x of t is 4, and when we multiply that 4 by 3 by 2, which is nothing but 4 into 1.5, we will be getting this 2. Okay, sorry, 4 into 3 by 2, we will be getting 4.5. Sorry, 4 into 3 by 2 means we will be getting 6. Actually here we have to perform 4 divided by 3 by 2, so we have to divide, right? So 4 divided by 3 by 2, so 4 divided by 3 by 2, just a minute. So what is the duration of x of t here? So x of t is 1, 2, 3, it is 3, not 4. Yes, x of t is not 4, it is 3, so I made a mistake. So here from -1 to 0, it is 1 unit, from 0 to 1 another 1 unit, from 1 to 2 another 1, so totally 3 units, it is not 4 units. Okay, so 2, the time duration is 2, it happens from -1 to 2, so 2 minus of -1, that is equal to 2 plus 1, that is equal to 3 units. Okay, so we have to divide this 3 units by 3 by 2. Okay, so actual x of t is extending for the duration of 3 time units, and when we perform this x of 3 by 2 operation, x of 3 by 2 of t for x of t, will have the entire signal in the range between -0.66 to 1.33, which is nothing but 2 units. Okay, so we got this 2 units by doing this operation, 3 divided by this 3 by 2, and here we will be having 3 divided by 3 into 2, and 1 divided by 1 by 2 is 2 units. So in this manner we got this, the total time duration. So the actual signal happened for 3 time units, but after performing this time scaling operation, this is taking 2 units. So the total time is compressed when we have the scaling factor greater than 1. Okay, so the same thing I have repeated for x of 2 by 3 into t. Here the scaling factor is less than 1, for which the duration is expanded. Okay, so here 3 divided by 2 by 3, which means 6 divided by 3 into 3, 9 divided by 2, that is equal to 4.5 units. Okay, so actually x of t was extending from -1 to 2, so that means 3 units. Now after performing this time scaling operation, here the factor by which t is multiplied by a value is greater than, is lesser than 1, it is 2 by 3. So we have 3 divided by 2 by 3, that is equal to 4.5 units. Okay, so the duration for which x of t is occurring was 3 units, 3 time units. Here after performing this scaling operation, the time of occurrence is 4.5 units expanded. Okay, here also, here in the left hand side, here we have performed the logical approach. 2 by 3 of t equal to minus 1, that means which implies t equal to minus 3 by 2. Minus 3 by 2 is nothing but minus 1.5. So the thing that happened at t equal to minus 1 is happening at t equal to minus 1.5 in this time scaling, after time scaling. Okay, similarly 2 by 3 of t equal to 0, t equal to 0. Okay, so the thing that happened at t equal to 0 for x of t should happen at t equal to 0 for x of 2 by 3 t also. Okay, then 2 by 3 of t equal to 1 here, which implies t is equal to 3 by 2. So the thing that happened at t equal to 1 for x of t should happen at t equal to 3 by 2, that is 1.5 for x of 2 by 3 into t. So from 0 to 1.5 we have amplitude of 2 units. Similarly from 1.5 to 3 we have amplitude of 1 unit. So like that we can apply the logical approach also to solve this problem. Okay, so both the things are applicable, traditional approach and logical approach. Okay, now x of 2t plus 3. So this is asked in the problem. X of 2t plus 3 means here we are performing time shifting operation and also we are performing time scaling operation. We should not forget the order. We should perform the order like this: first time shifting, then time scaling, and then time reversal. Here time reversal is not asked, so no need to perform that. We have to perform time shifting first and then we have to apply time scaling. So time shifting means x of t plus 3. Here we are performing x of t plus 3. T plus 3 means advanced by, that signal is advanced by 3 time units. So instead of happening from minus 1 to 2, it is happening from minus 4 to 1. So advanced by 3 time units. Okay, then to this x of t plus 3 we are performing time scaling operation. That means we are dividing the time at which the signal is happening by a value of 2, by a factor of 2. Okay, so minus 4 divided by 2 is minus 4 divided by 2 is minus 2, minus 3 divided by 2 is minus 1.5, then minus 2 divided by 2 is minus 1, minus 1 divided by 2 is minus 0.5. Okay, so the signal should extend from minus 2 to minus 0.5 for x of 2t plus 3 instead of from minus 4 to minus 1 for x of 2 plus 3. Okay, so here it is happening like this: minus 2 to minus 0.5 it is happening. Okay, so the signal is compressed by 2 times. So initially the signal extended for 3 units. Now here it is extending for only for 1.5 units. From minus 2 to minus 0.5 it is 1.5 units. So in this manner we can perform. So this is traditional approach, and when we apply logical thought to this problem, again we are performing the same approach, the same thing 2t plus 3 equal to 1. So this is applicable only to x of t. You should not apply this method to x of t plus 3. Okay, so here this logic is useful when we take x of t directly, when we are able to plot x of 2t plus 3 directly from x of t. Okay, we should not do any time shifting or time scaling operation even before doing it. Even if we have x of t, immediately we can apply this logical approach to derive x of 2t plus 3. So 2t plus 3 2t plus 3 equal to minus 1, which implies t equal to minus 2, 2t plus 3 equal to 0, which implies t equal to minus 1.5, 2t plus 3 equal to 1, which implies t equal to minus 1, 2t plus 3 equal to 2, which implies t equal to minus 0.5. So here the signal instead of occurring from minus 1 to 2, it is occurring from minus 2 to minus 0.5. Instead of 3 units for x of t, here the time period of x of 2t plus 3 is 1.5 units. Okay, so we have got the same signal. Okay, both in traditional approach and also with the logical approach. And here what happens if we have both time scaling also, time reversal also? So in the question, time reversal kind of problem is not asked. So here we are again introducing a negative sign. So what happens to the signal if we have this kind of notations, x of minus 2t plus 3? So here in this signal we have time, all the three: time shifting, time scaling, and one minus is here, which implies it is time reversal. Okay, so we have to perform in this order: time shifting, first we have to perform time shifting, next we have to perform time scaling, and after that we have to perform time reversal. We have already performed time shifting and time scaling here. Okay, so after performing time shifting and time scaling, we will have this signal. So now at last we have to apply time reversal operation to this signal. When we apply time reversal operation to this signal, so the thing is mirror image. So the thing that is happening from -2 to -0.5 should happen at +0.5 to +2. Okay, so -2 to -0.5 we have a ramp signal. So after applying time reversal from +2 to +0.5 or +1.5 we will have a ramp signal, and there is an amplitude of 2 units from -1.5 to -1. So after applying time reversal from +1.5 to +1 we will be having amplitude of 2 units. Then from -1 to -0.5 we have an amplitude of 1 unit. So after applying time reversal operation we will have the amplitude of 1 unit from +1 to +0.5. so that is what we will be having, and that is clearly mentioned here. Okay, so that is clearly mentioned here. Okay, so from +2 to +1.5, then +1.5 to +1 we have 2 units, amplitude with magnitude of 2, and from +1 to +1.5 we have amplitude with magnitude 1. Okay, so in this manner we can do, and the same thing we can apply directly using the logical approach. Instead of equating 2t plus 3 to -1, we are equating -2t plus 3 equal to -1, which implies t equal to 2, -2t plus 3 equal to 0, which implies t equal to. So the same kind of approach we are doing, and when we plot the signal we will be having this version, which is same as that of the traditional approach, which is same as that of the signal that we got after traditional approach. Okay, so with this I hope you might have understood the entire signal processing, signal manipulation, all the thing, amplitude scaling, time shifting, time reversal, then time scaling operation. So you can solve any kind of problem asked related to signal manipulation. So I am very much confident about that, and as an exercise you can have this discrete signal. So this is a question that was asked in December 2018 Anna University semester examination under the subject code EC8352, and the name of the subject is signals and systems. Okay, so here the question is this one, x of n is given. Here instead of a continuous signal a discrete signal is given, and the students are asked to find x of n minus 2, x of n plus 1, x of minus n, x of minus n plus 1, x of 2n, x of minus 2n plus 1. So I leave this problem as an exercise for you. You try to solve it, and if you have any doubt kindly leave it in the comment box, and if it is required I will record a video on this problem too. Thank you. Meet you again in another video, and if you have any comment or any suggestions you can leave in the comment box, and don't forget to subscribe my channel. Kindly like and share the video. Meet you again in another video. Until then, bye. Thank you.